Chữa hết được cái tutorial đầu tiên. Một vật chất
có hai option. Một là tuần sau, tuần sau hai là thầy có thể đợi thêm một tuần sau nữa, tức là tuần sau mình đến tuần sau đấy thì mình sẽ thi, thì để các bạn có thêm thời gian để hoàn thành cái tutorial đến tức là cái nội dung cái việc sẽ thi đến bài 6, hết bài ngày hôm nay. Ok, nhưng mà các bạn thay vì tuần tới, tuần tới thì tuần sau nó mới thi được không? Ok, các em muốn thi luôn cho sau. Việc thứ hai là thầy muốn hỏi là tất cả các bạn đều có máy tính xách tay đúng không? Có, đúng không? Thì chúng ta có thể thi trên Moodle. Thi trên Moodle thì submit một cái là biết điểm luôn.
nhưng mà không thi thì không có điểm.
Đó. Thì đều phải in giấy.
In giấy.
Thế khi nào các em thi môn như kiểu môn của giáo sư Lê Cô biết nghiệp chưa? Mới đi như từ sinh ra.
Vâng.
Tuần lần này vừa lấy xong. Thi trên
Mua đồ của máy trường. Chỗ phòng tin phòng 503 cả tầng 5.
Thế làm sao mà các em thi được tổng cộng là 612 lớp thì thi
20 phút ca. 20 phút mỗi người. Chia cho ca. Cứ 20 phút một ca.
20 phút thì không làm hóa được.
Các thầy có định 20 phút toán.
Tại vì hóa thì chúng ta phải thi 90 phút. 40 câu.
40 câu.
Mỗi câu không 15 điểm.
Có những nội dung gì? Được hàn 6 cái này.
Nếu như các thanh niên thi bằng máy của mình thì cheat có dễ hơn không?
Chẳng cheat được, chẳng biết cheat cái gì. Chẳng cheat.
Yên tâm này, thầy có đội coi thi áp hôn mà. Thầy có đội coi thi chuyên nghiệp ạ. Đội đấy bây giờ chỉ đang trả lát thầy vào kinh khen này là mọi người. Ok, thầy thi để mình sẽ cho đội phòng vận tải để các bạn sẽ thi chuyên này của các bạn ở trên đoạn đường này. Tại vì thi 90 phút và thi 20 phút vào để không nổi. Không có câu hỏi ngu đâu. Đó là mình sẽ thi ở đây. Thì ở đây
Thầy vừa nói chút môn.
thì đúng giờ học này luôn.
Đúng giờ học này.
Để thầy sẽ trao đổi lại với các thầy trong nhóm làm tutor cho các em. Nhưng tinh thần là cứ sau khi mà kết thúc bài 6 này là các bạn có thể thi tutor được. Ok, thầy sẽ để cho các bạn. Ok. Không sao cả, thì chúng ta chốt là thi tutor khi những tuần này chúng ta thi đến hết bài 6 đúng không? Thì có thể là tuần tới thì sẽ là hơi sớm với các bạn, để tuần sau thì mình sẽ trao đổi với các thầy. Ok? Dễ hả?
Không dễ. Dễ chết.
Mình chưa ra được. Trừ khi là mình dò mình thì mình chưa.
Dễ chết.
Okay, so it's time. Shall we start our session? So, in our previous lecture, we have discussed about the atomic structure, and mainly we focus about the arrangement of electrons, right? Yes. And we start first with the question of the hydrogen, the simplest atom with only one electron. We describe in the case of hydrogen with only one electron, how electron will position when we compare with the nuclei. because we know that electron is negative, proton, the nuclei is positive. So there is attractive force between the nuclei and electron. So we describe how the distance between the nuclei and electron will be. In the case of one electron, what could be the energy state? So we talk about the allowed energy state. Electron cannot stand in any distance, but only in few precise distance, and with each distance from the nuclei, it will have one precise energy. And when electron transfer from this to another state to another state, it can either absorb or emit energy. Then we talk about the concept of orbit and orbital. In the case of orbits, it should know precisely the position of electron any moment if you know the movement, the velocity of electron. But actually we cannot know. So we move from the precise orbit to the orbital, where we talk about the probability to find electron in the space around the nuclei. Okay, so you have the concept of orbital. So we talk about the 4 quantum number. Actually, in the previous lecture, we talk about 3 quantum number, N, L, and L, describe the orbital. So basically, the first quantum number will describe about the size and the energy of the orbital. How big the orbital will be, what could be the energy if electron localized in the orbital. And then you talk about the shape, the topology, if you want, of this orbital, whether it's a sphere or anything else. And you talk about the orientation of the orbital in the space, right? Because we talk about the spherical coordinate. So that's all the key information you learn from the last lecture. Okay? So to warm up a little bit, so here you have the 5 orbital D, and how we apply the orbital D to understand some physical and chemical phenomena. Okay? So you have these 3 exercises. I invite you guys to work at home. We discuss at the end of the lecture. So to warm up, first question, please. Can you work on this question? You have 2 minutes. Is energy emitted or absorbed when the following electronic transition occurs in hydrogen? First, A, from n equal to 4 to n equal to 2, whether you absorb or emit energy. B, from an object with radius 2.1 angstrom to the one bigger with 8 angstrom, whether you absorb or emit energy. If you add an electron to the proton, S plus, and end up with the n equal to 3, what could be the energy released or emitted? Are the questions clear? Okay, please. So, when we, in the class, when we try to discuss about this kind of question, you guys, you can discuss, okay? No problem. Okay? But in the examination, do not.
Chắc là em biết ai
we first discuss about the question A, can
I think, I think the rule of long energy is things and from 4 to 2. I think that's the formula and I think it's 13.6 over n squared multiple by power 0. I think it's absorbing.
anyone can explain why you make the electron transfer from n equal to 4 to the second layer n equal to 2, you will have the emission. Anyone can comment? Chưa gì nữa ạ? So, for the question A, what would be the answer? Absorption or emission?
Emission.
Emission, right?
Chu tham
So why?
2 lần
Because, huh?
phòng
Okay, in the question A, the energy is on the level 4 and it's need to emission the energy to reach the level the n number 2. Because it's in a higher level, so they need to bring to the emission to
Okay, so you know that when you increase the main quantum number, the energy will increase, right? So the energy will increase. It means that when it comes back to the n equal to 2, it will emit. Because of the law of energy conservation, energy cannot be disappear, cannot be created, but it can only transfer from this form to another form. So when you have a higher energy level, n equal to 4, you go to n equal to 2, you need to end this. Okay? In the inverse way, when you go from n2, the second layer, to the fourth layer, you go from a lower energy to higher energy, you need to absorb energy to bring it up. Okay? So how about the question B? You go from smaller size to a bigger size. What could be the energy, whether you need to absorb or you emit? Why? So, if you go from a smaller size, I mean closer to the nuclei, right? So the energy will be lower. You go to the bigger size, at a higher quantum number, right? When the main quantum number n increase, you will increase the energy, and when the quantum numbers n increase, you increase the orbital size as well, right? So when you go from the smaller orbital size to the bigger one, that means you go from the smaller quantum number n to the bigger one, right? So in that case, you go from lower energy to bigger energy, so you need to provide energy into this. So this case, you need, the system need absorb energy. Is it clear? So it means that if you have an electron, here you have nuclei, if you have an electron at this distance, you want to bring it to this distance further, you need to put energy inside. Okay? Of course, when you bring the electron from this distance to the vacuum, that means it's disappear. Electron, I mean, it transfers completely out of the atom. You need to put a lot of energy, right? Is it clear? Because it goes from this distance to the infinity. Is it clear? Okay. So how about the question C? It will absorb or emit.
Absorb.
Why?
I see the keyword
So to answer this question, first you need to think. When you have a proton, S plus, the atom of hydrogen, you have only one electron, right?
Yes.
When you have S plus, that means you remove one electron, so A plus have 0 electron. Is it correct? Okay? So now the first question is, if you add one electron to the system which have 0 electron, where the electron will stand? In the most stable one. In the most stable energy state. Where electron will stand? N equal to 1, 2, 3, 4, or what else? 1, right? Because there, the electron will be the most stable one, close to the nucleus. Right? So basically, when you add the third electron to the system, the electron will stand here. Okay? If now you want this electron to move to the n equal to 3, that means you need to bring from here to here. Okay? So you need to provide energy to make this process happen. Okay? Clear? Okay. Next question is here. Can you work on this? For the table that's follow, which orbital goes with the quantum number, don't worry about x, y, z. If the quantum number are not allowed, then write not allowed. This is something you have already in the senior generation, got already in the middle. So for example, when you have n equal to 2, so the electron in the second layer, L equal to 1, that means you have an orbital p, ml minus 1, then you have orbital 2p. Okay? So now if you have n equal to 1, what will be the orbital you have? The second 1, 0, 0, what will be the orbital?
Chưa hiểu thầy nói gì đâu. Chưa hiểu thầy bài nói gì đâu. Chắc là 2 là nó on theo.
1s, right? So when you have L equal to 0, that means you have orbital s. And 1, that means you have orbital in the first layer. So you have orbital 1s, right? How many orbital s you have? Only one, right? It have no direction. It's very good. The first one, 3 minus 3, 2, what could be the orbital? Not allowed. Okay. Why? Okay. Okay. L can only accept the value from 0 to n minus 1, right? So in the case you have n equal to 3, that means L can be only 0, 1, 2. Cannot be negative 3. Okay? So this one is not allowed. How about 3, 2, minus 2? What could be the orbital?
Và đây. Ở đây. 3D. 3D.
Huh? 3D, right?
Nó là cái này.
N equal to 3, that means you have orbital in the third layer. 3. L equal to 2, that means you have orbital D. So you have 3D orbital. 2, 0, minus 1. 2s. 0, 0, 0. Not allowed, right? Why?
Because all the figures is zeros.
Is it acceptable to have a main quantum number 0? No, right? 4, 2, 1. 4D, right? 5, 3, 0. 5F, right? Okay, good, excellent, thank you. You see, it's quite easy, right?
No.
Okay, so let's continue with the system, the atom, where you have more than one electron. We call the system with many electron atom, many can be 2, 3, etc. So, you remember that for the case of hydrogen atom, where you have only one electron, all the orbital in the subcell will have the same energy. That means you have 2s orbital will have the same energy with 2p. Okay? But when you have a system with more than one electron, then the orbital 2s and 2p will be not at the same energy level anymore. You see that 2s will have lower energy than 2p. 3s will be lower energy than 3b and 3d and so on. Okay? So the energy of an orbital increases with increasing value of L. So when you have an S, that means L equal to 0, P, L equal to 1, and D, L equal to 2. When it increase from 0 to 1 and to 2, from S, P, and D, the energy will increase. In the case of hydrogen, all the orbitals will have the same energy level. Okay? But when you move to the system with more than one electron, the energy level will increase from F to D to D. So here it's quite easy to understand, quite easy to remember. If you want for the case of hydrogen on the left side, you have N equal to 1, 1s, and 2, you have 2s, 2b at the same energy level, and 3, you have at the same energy level. But when you move to the many electron system, you have energy splitting from 2s, 2b, 3s, 2b, and so on. Okay? So you can see that comparing with 4s, the orbital 3d will have higher energy. So that means now if you put electron in the system, electron will fill from 1s, 2s, 2b, 3s, 3b, 4s, and 3b. That means the electron in the many electron system will occupy first the orbital 4s before it occupies the orbital 3b. Even the distance from orbital 4s to the nucleus is longer than the distance from the 3d to nucleus. That means electrons prefer to occupy the long distance first, even because it has low energy. Okay? So little bit more. We say that we have already 3 quantum numbers, N, L, and ML, to describe the orbital. How many electrons can occupy one single orbital? Like say 2bx. How many electrons can occupy? So people describe like following. Electrons have intrinsic property called spin that causes each electron to behave like a tiny magnet. Because electron is particle, it has negative charge. So when it moves, it will behave like a magnet. Okay? So how people describe easily and simply to understand about the movement of electron? So you can imagine that you have an electron like a particle like this one. Okay? So when electron moves like this way, it will create the magnet. Okay? So basically, when you have the electron, you have 2 movement directions from this one and this one. So clockwise and anti-clockwise, right? So when we have this 2 directions of movement, we say that electron will have 2 directions of movement if we want, and it's corresponding with 2 values of what we call the spin. It can be up or down. Okay? So people say the electron passes through a tiny sphere spinning around one axis. So you have 2 possibilities, one in this direction and one in the other direction. So it means that when you transfer this direction in one mathematical value and this direction in another mathematical value, we have 2 mathematical values. Okay? But actually it's not correct because you know that electron is point line, is dimensionless, right? If you have a point movement, you have no dimension, that means you cannot have a direction of the movement. You get what I mean? And so basically the electron will move in like this, it will not like this one. Okay? So when they solve the Schrodinger equation, they figure out that basically you have 2 options, mathematical value. One we call the half positive and one minus positive is corresponding to the physical mean of movement by this one and movement by this one. So we call the 2 values are the spin of electron. Okay? Even pure physical meaning is not really correct because electron is dimensionless. So explaining the electron moving by this one or moving by this one is not really correct. However, when they solve the mathematical equation, the Schrodinger equation, they figure out that the electron have only 2 values. Okay? So we call the spin up and spin down. Positive value and negative value, spin up and spin down. And basically you can say that if you have minus, negative and positive half, that means the probability to have electron in the spin up is 50%. And probability to have electron is spin down is 50%. You have only 2 possibilities, up and down, right? So the probability is 50%, so that's why they represent the value by minus 1/2 or positive 1/2. Okay? So now, one orbital is defined by N, L, and ML, 3 quantum numbers, and electron can be defined by the 4th quantum number which is spin. So spin have only 2 values, up and down, positive and negative half. So, and we have the Pauli exclusion principle saying that no 2 electrons in one atom can have the same set of 4 quantum numbers. That means the 2 electrons, any 2 electrons in the atom can accept to have 3 main quantum numbers similar, but the 4th one, the spin, should be different. Okay? None of electron, 2 electrons in one atom can have the same set of 4 quantum numbers. So say, no electron in one atom can have exactly 4 quantum numbers identical. Is it clear? It also says you have two orbitals, let's say 1s, sorry, if you have orbital 1s, okay, so you have n equal to 1, L equal to 0, okay, ML equal to 0 as well. So you have three quantum number 1, 0, 0. Now, in this orbital 1s, you can have only two electrons which have one spin positive and one spin negative. Because the fourth quantum number with spin will be different. But you cannot have three electrons. Because if you have three electrons, the third one will have either spin positive or negative, right? And if it have positive, it will be similar to the first one, first electron. And if you have negative spin, it will have similarity 4 quantum number similar to the second electron. So by this Pauli expression, you can understand that in one given orbital, you can occupy by only 2 electrons. And the 2 electrons will have the same n, l, and l, but the spin quantum number will be opposite, up and down. Is it clear? Okay? Easy to understand, right? So, now, determine whether each of the following set of quantum number for the hydrogen atom are valid. If a set is not valid, indicate which of the quantum number have a value which is not correct. So, if you have n, so the set A, 4, 1, 2, minus half. So is this correct or not? No? Why?
The ML value must be smaller or equal to L.
Yes.
From
So the first one is not correct, right? N4 is okay, L1 is okay, so the orbital B, okay? But ML, you cannot have the value larger than L because ML accept only L, 0, minus L, right? So the A is not correct. How about B? Eh? What is B? How about B? Is it correct?
Yes.
Yes, right? So what would be the orbital in the set B you have?
4D.
4D.
4F, right? C, is it correct?
Yes. Yeah.
Yes. So what would be the orbital?
3
No.
P.
C, Lกับมาเลย
3B,
C
3D,
no,
right?
not equal to
How about D?
5S. I think it's mấy dạ
It's not correct, right?
Yes.
Because MS cannot have 0.
lú nha.
How about E?
is
2D.
2D.
Do you have orbital 2D?
No.
Why?
Yeah, just only E. No, so this is not wrong.
This value is not correct, right? Right? Because it's accept only from 0 to n minus 1. It can, maximum can be 1, right? Look, the following electron configuration represent excited state, identify the element, and why its ground state contains electron configuration. But this one we learn later, no problem. And move on. Now, important. You have two electrons in the same orbital, right? One spin up like this, and one spin down like this one. Okay? The two electrons in the same orbital, so it means they will have the same energy level. Okay? So you don't know which one is up, which one is down. Is it clear? When you stand from outside, you look inside, you have two electrons like this one. You know that you have two electrons inside, so you know very well that because of the Pauli exclusion principle, the two electrons, one should be up and one should be down. My question is that, technically, experimentally, how can you know which one is up and which one is down? Am I clear in my question? So how can we see, how can we distinguish the one with up speed and the one with down speed? Experimentally. Is it possible to visualize or not? Imagine. Do you understand my question?
How to define?
I would like to invite you to think about the concept, not to remember the concept. So let's say, imagine, I have 2 electrons in one orbital. Okay, let's say in one orbital px. Okay, and I understand that if the 2 electrons in one orbital, they will have the same energy, right? But because of the Pauli exclusion, I know that the 2 electrons should have one speed up and one speed down in 2 directions like this one, right? Okay? But they are in the same energy level. If they are in different energy level, like this one, okay, I know which one is up, which one is down, by sending a photon to see whether it's absorbed or released. Okay? But now, if they are in the same energy level, how I can distinguish the 2 electrons, which one is up and which one is down? Any suggestion? Look, and take the exam quite easy to understand. Right? You are in this class. You are all students of USS in the same class, general chemistry 1, given by form. Basically, for me now, all of you are equal. Okay? Perfectly equal. There's no one better than another one. Now, Professor Lee Mai Thach, the rector of USS, said that I need to find out the excellent guy to give scholarship. Okay? I mean, the guy with higher energy. To find the guy to receive scholarship. How I can do? I cannot come to randomly to say that, okay, this guy will have scholarship, right? But I know that some of you will behave, will have better performance in chemistry than the other guy. But how I can see, how I can figure out who is better? You understand my question? All of you are now similar. Like you are, some of you will have spin up, some of you will have spin down. But all of you have the same energy level in the same class, so I cannot provide scholarship to anyone. Now my question is that how I can answer the question, provide a vector to find out which one have spin up to receive a scholarship. Can you comment?
So, based on the question, I think we will look at the efficiency and the score which candidate in this room will obtain, and then we will find out which one has the highest efficiency and the highest score, and we will consider the person.
But how can we see which one has a better score?
I guess through the exam.
Yes. Exactly what we do. Now, the 2 electrons. So now, if I want to find out who's the best, who's higher, better performance than other one, I have to provide you examination, right? After the examination, some will fail, some will success. Okay? So those success, I define you have higher potential, that means you have high speed into one. Okay? So imagine that more difficult examination will be better separation of the two categories will be, right? Is it correct? If I give you the question, examination, that what could be the result of 1 plus 1 equal, all of you will have the correct answer, right? Is it? No? Okay, sorry. Take it easy. Assume that all of you have the same correct answer, then the examination will be not useful. So now the idea is the same. You see, the scientists will have the same manner of thinking and the same idea like we are talking. It's not like genius come up with a brilliant idea to solve the question nobody can solve. Basically, all of us are genius if you want to think. Okay? So the question is following. To distinguish who one is better, we need to provide examination. So now you have 2 electrons, 1 and that, right? So if you apply one examination, which is external magnetic field in this direction. So when you have the spin and the external field in the same direction, the energy will be lower. But if you have the electron, the external field like this one, and the electron will be in the opposite, they will push up. So the electron in the opposite direction will have go at a higher energy level. You get what I mean? So you start from 2 spins at the same energy level, you apply external field, one will go at the lower one and one will go at the higher energy level. So you separate the 2 electrons. So now you know which one is higher energy, that means it have opposite direction, so it have spin down, and if you have something at a lower energy, you have spin up. Is it understandable? So when you apply the external field stronger, the speed, we call the energy splitting between the 2 guys will be larger. Like you have harder examination, you see the gap between the excellent guy and the not excellent guy will be huge. Am I clear? Okay? So that's the concept when you want to define inside an atom which one has spin up and which one has spin down by applying. So here, when you have the external field equal to 0, the 2 spin will be the same. When you increase the field, then the speed in between the 2 spin will be increased. Okay? So that's the concept. And they apply a lot of this one to identify the electron, single electron with the spin, the spin up and down in the atom. Okay? So when you learn about the spin of electron, positive half or negative half, you just remember. Right? At high school, basically, you remember that and you work perfectly. But you don't care about what could be the application of this one. What is the meaning behind? Okay? So imagine now, if you have one atom which have only one electron. So the electron have only one spin, right? So the electron will look like in the lower energy level. So when you try to excite it up, it will go up, and when it spin down, it will emit energy that you can detect. Okay? Imagine now, if you have molybdenum 5 plus, oxidation state 5. That means it has only one electron. Only one electron, that means it has only one spin. When you excite, it can go up, and when you release, it will go down, so you can detect the emission energy. But now if you have molybdenum 6 plus, that means you have 0 electron. So whatever 0 electron, that means there are no up, no down, right? So whatever the energy you apply here, you have no splitting. You get what I mean? So it means that if you have more than 6 plus, in this methodology, it will be silent. You will not see anything. No signal, because it cannot absorb, it cannot emit. But if you have more than 5 plus, you have only one electron, you can detect it by absorption and emission. That you can see. So it has to recognize, for example, if you have camera, and people ask you whether the oxidation state of molybdenum is 5 or 6 plus, Normally you don't know, right? Molybdenum is molybdenum. If you want to know about the 6 glass or 5 glass, you don't know how to do. And at high school, they invent a lot of chemical reaction to say that if the molybdenum 5, it will react with this one like this way, and if 6 react with this one like the other way, right? So, for example, you work about the recognition of the iron 2, iron 3. You remember, right? By using the chemical reaction. But actually, nowadays in the modern technology, no one uses chemical reaction anymore. So you learn that when you get graduate, no one will use. So you feel that all of the things you learn in high school, in university, will be no use. Because if you learn something, people forget already. So nowadays, if you want to recognize whether you have molybdenum 5 or molybdenum 6, you use this kind of technology. Because you learn about the spin. And in the molybdenum 6, you have no spin, you have no electron, so there's no spin. You apply external field, then nothing happens. But if you have molybdenum 5 glass, you have only one electron. So basically, it will be at low energy. When you apply external field, it will jump to the high energy, right? Jump up, that means it absorbs energy external one, and when it go down back to the ground state, it will emit. So you detect this energy, you say that okay, there's difference between the molybdenum 6, nothing happened, and molybdenum 5, which one absorption and one emission. Am I clear in my explanation? Yes. Okay? So that's something we use in our problem. There's the same for the nuclide. Okay. So remember, no 2 electrons in one atom can have the same set of 4 quantum number. Okay. So it means that in one orbital with 3 quantum number N, L, and L, similar, this can look like only 2 electrons with one spin up and one spin down. So people try to draw, to show how we can describe the electron in orbital. So you use one box, like one orbital, and you use one arrows, like one electron. So when you have arrow up, it means the spin up. You have arrow down, it means the spin down. So you have one electron, all the time the electron will have the spin up. Okay? That by definition, if you want. So then when you have the second electron will have spin down, like in this case. And when you have orbital, like all occupied by a pair of electrons, one up and one down, we call the orbital have full orbital. Okay? That means the orbital fully occupied by 2 electrons. Okay? So we talk about the electron configuration, that's the way in which the electrons are distributed among the various orbitals. Basically, you pick up a number of electrons, you put in the atom. So by the law of energy stability, if you want, the first electron will occupy the lowest orbital in terms of energy, because lower energy, lower potential means more stable one. Okay? And you want to control, you want to build something is more stable. So you have a number of electrons, 2, 3, 4, whatever you want. The first electron you put in the lower energy orbital, and then you go up until the moment you have no more electron to feed. Okay? So the most stable electron configuration of an atom is the ground state, the lowest possible energy state. Okay? So we feed from the bottom to up. Orbitals are filled in order of increasing energy that I explained to you with no more than 2 electrons per orbital because of Pauli exclusion rule. Okay? So look at the case of lithium. Lithium have 3 electrons, so you have one s orbital can accumulate 2 electrons. So you see the first boat, one s with 2 electrons, one up and one down. And the third electron you put in the second orbital, which have higher energy than 2s, but lower energy than 2p, right? So you have one orbital, 2s. Okay? So now, if you look at this electron configuration, you write electron configuration like 1s2, 2s1. To say that you have 2 electrons in 1s and 1 electron in 2s. that you learned already. I remember in the grade 10 at high school, right? So what about nitrogen? You have 7 electrons, right? So first, you put 2 electrons in 1s. Second, you put 2 electrons in 2s because you have higher energy. Then you have 3 electrons. 3 electrons now you need to put in 2p. Okay? And 2p can occupy maximum 6 electrons. So it's okay, you can put 3 electrons here. So now, how about we put 1 pair of electrons in 2p and the next one will be 3. And that means only 1 electron. In this case, we say that it's not the most stable state. Because when you have a pair of electrons like this, it's not the most stable one. So what would be the case? You have the rule proposed by Kuhn. Say that for degenerate orbital, that means the orbital with the same energy, the lowest energy state is obtained when number of electrons with the same spin is maximized. That means if you have the same orbital, if you have orbital with the same state of energy, the electron will prefer to occupy to make the number of single electron, not pair electron, is maximum. You have maximum single electron. So here, if you apply that this way, you have 3 orbital B at the same energy level. So if you put by Kuhn rule, you put 3 electrons, single like this, and pair electron. This energy state will be the most stable one. Okay? So it looks like in practice, you take 3 electrons, you fill 1, 2, 3 first, and the fourth one you will put here, the fifth one will be here, and the sixth one will be here. Okay? If you have 2 electrons, you put first one here and the second one here. Okay? But don't try to put the pair energy. Why? Why? Why you say that when you have degenerate orbital, the orbital with the same energy, the electron will prefer to stand alone. Right? So if you look the lecture by reading this rule, you can understand like, if you want to put 2 electrons instead of being individual, to be a pair electron like this, you need to pay energy. Right?
Yes.
Why? Because 2 electrons are negative charge. So they will have exclusion interaction. They don't like each other if you want. Okay? Is it correct? So if you want to force the 2 guys, normally they prefer to be free individual. To become a couple, you need to pay energy to force them to be together. Okay? So paying external energy to force them to be together is not really economy in terms of energy. So if you don't force them, they prefer to be individual. Unpaired. Okay? Like at home, you guys, you have younger brother, right? Do you prefer to share the room with him? No, right? Is it correct? It will come to your parents to say that, hey, Papa, Mama, I do prefer to be alone because I want to work in the good condition, to have a good score at school. You invent whatever you want, right? And you say that the most stable state will be each of you will have individual room. Right? Is it correct? Now, John Barrow said that no. Okay? You need to be together. Because I need to rent this room. Okay? Then they need to satisfy something for you. Is it correct? They need to force you to be together. Otherwise, you prefer each of you will have an individual room. So the same for electron if you want. Because when you have 2 guys individual in 2 rooms, the freedom will be not the same. The liberty if you want will be not the same. The freedom will be different. But when you live in the same room, X of you will look the other one to behave. So you lost the freedom. You get what I mean? Yes or no?
Yes.
So if your parents want you guys to be alone, to be together, they need to force you and to pay some price for you guys. So the same here. If you have two electrons that prefer to occupy the same room with the same energy, with the same configuration, but they prefer to be alone. If they want to force them to be together, then you need to pay energy to force them. And also in terms of spin, when you have two electrons individual, they will have the same spin, up or down, right? Is it correct?
Yes.
But when you push them, force them to be in the same orbital, one need to change the spin, right? Because you cannot put the two electrons in the same with same spin in the same orbital, because it will violate the Pauli exclusion rule. Is it clear? And imagine that crazy, one electron is moving like this. And now you force them to be back, like this one. Change the movement direction, right? Spin up like this. And then you say, okay, the force to be back is we need to change the movement direction. So something is moving like this, you want to make it back this direction, you need to put energy. Is it correct? Can you understand or not? Very easy explanation, right? You guys, you don't prefer to pair with someone, so they need to pay something for something. The same concept later when you make a chemical bond. Basically, when you make a chemical bond, you make a pair of electrons, right? So you need to gain something before you do like this. Like sometimes I invite you guys in the previous generation. Think about a chemical bond by the same way as this one. Very simple one. You and your friend. Even you are a very good friend. Okay? And each of you, each month will receive energy, that means money from the parent, 3 million Vietnam đồng per month, right? Okay? And each of you at the end of the month, all money gone. Okay? So each of you guys will use 3 million. That means 2 guys will use 6 million. Now, you have 2 options. One, you keep continuing like that, having free, have good freedom, but at the end of the month, you don't have any money to go to coffee or something. You have a second option is that you share a room with the other friend. Okay? And at the end of the month, you can save money because you share a room. But when you share a room, you lost your freedom, right? If this one, if the roommate wake up, very likely that he wake up as well, because he or she make noise. Okay? That means you lost the freedom, you change your behavior. But at the end of the month, you can save money. So in that case, you try to force yourself to make the roommate to share a room with him. So the atom accept to make the chemical bond if they can save energy. But if you share the room with another friend, and when you share a room, you drink more, you have more party, you use more money. So at the end of the month, you have no money either. You owe money you wrong, but you lost the freedom. So this kind of sharing room will not be stable. Some moment you say that, okay, stop. So it means that you cannot accept to make a chemical bond if you skip the same energy or you use more energy than what you have. You can make a chemical bond if you save energy. You accept to lose your freedom to share room if at the end of the month you can save money. So that's easy to understand, right? The chemical bond. Like. So here the same thing. So when you have 2 electrons, you want to put it in the pair, we have energy, pairing energy. That means you need to put energy inside to make a pair. Okay. So, easy to understand. if you have 3 electrons, in the case of lithium, you have one single electron, 3 electrons in 2s, and if you keep 4, it will evaluate like this. So the way you make the electron configuration. Okay? So if you take this one, sometimes you have a difficulty to remember the order of the energy orbital, right? Sometimes you can feel what could be the lower energy 4s and 3d, right? So you can remember by this one. 1s, 2s, 3s, 4s, 5s, and so on. So you fit an electron configuration in the arrow direction. First you put in the 1s, second 2s, and then you put in 2b, 3s, 3b, 4s, 3d, 4b, 5s, and so on. So by this direction, okay? It's quite easy to understand. However, that's something if you are student good at math and good at physics, you don't like chemistry. Because the book of chemistry, without exception, is like this. Okay? And the book of chemistry, with exception, is like this. That means, in the chemistry, you try to establish rule. But you have a lot of exception of the rule. Not like in the math, you have one equation, there are no exception. Or very few exceptions. But in the chemistry, you have quite a lot of exceptions. And sometimes, the chemists say that the beauty of chemistry is not in the rule, but in the exception. I don't know whether you are physicists this remark or not, but it's reality. Okay? For example, you have some exception in this one. We say that orbital 4s have lower energy than 3d, so the electron will prefer to occupy 4s before it's occupied 3d. The same for 4s and 5s, 4d and 4f, for example. However, you have an exception. If you pick up the pair copper, okay? So normally, you will have a copper 4s2 and orbital d, 3d, 9, right? Because 4s are the lower energy, so you need to put 2 electrons in 4s first before you put 9 electrons in 3d. Okay? But in reality, you will have the real configuration, which is 1s and 3d 10. You see it's inverse. That's one exception. So for the case of chromium, normally you will have 4s2 and 3d5, 4. Sorry, because you have a 6 electron. But then, in reality, it will occupy 1 electron in 4s and 5 electrons in 3d. So here you can have first remark is that the orbital d will prefer to half occupied or fully occupied. That means d5 or d10 will be preferred than the d4 or d9. Okay? That's the first thing. So, in the chemistry, we don't like to remember this kind of exception. Because, to be honest, I can't remember. I get old already, but how can I remember a lot of things like this? So, how people did? Basically, what we are interested in is not the position of the electron in S or D. What we are really interested in is how the electron will behave in chemical reaction. Okay? So we figure out that in the case of copper, 11 electrons will behave by the same manner in one. Okay? So you can distinguish the energy level of 4s and 3d. However, in the chemical reaction, you cannot distinguish whether the electron S or D will behave first, will react first. So we say, instead of saying that copper is element with 1s and 10 electron D, we say that copper is 11 electron D. Or we go D11. same way. We cannot distinguish which one and which one. Okay? So we write the electron configuration like this, but I define like 11 electron D. Because 11 electron will behave like the same number. Can you get my point? Even you know very well that D11 cannot exist. Because D have a 5 electron, 5 orbitals, so it can occupy maximum 10 electrons. Right? But because 4s and 3d are a comparable energy level, and in the chemical reaction that we are interested in, they behave by the same manner. So I call copper is D11 electron, or D11 element. So here is copper. So now, if we talk about the copper 2 plus, okay? So what would be the electron configuration of copper 2 plus? Basically, you would expect F2D7, right? Is correct? Huh? But then, in the chemistry point of view, we call it 11. This specimen is D9. Because 9 electron, 2s and 7 in D will be the same. Okay? By the same way, if we have copper 1, you have D10. Even you have F2D8. You got my point? So by the same concept, if you have a chromium here, you say chromium is in D6. Okay? So that's why now if you open the periodic table of element, you will see that chromium in the group of 6b. Because B representing the element with the orbital D electron. And 6 represent the total electron S and D that behave like electron D in this element. You don't put chromium in group 5b, but you put in the 6d, right? Am I clear in my explanation? Yes? So sorry for that. If you forget about the exception in the chemistry, you will get confused by thinking logically like a mathematician or physicist. Okay? Try to understand in the big picture. What we are interested in is not where electrons go black, but how the electron behave in the chemical reaction. So S or D, we put together, we say D11, D7, D8, D10. So for example, quickly later, when we have molybdenum, we say that molybdenum is D6. That means I don't care whether it's F1D5 or F2D4. I say it has 6 electron D. Okay? And then when it have become like molybdenum 5 plus, I will say quickly, you remove 5 electrons, it becomes D1. Okay? And if you have molybdenum 6 plus, you will say that this D0 is have 0 electron D in this item. Is it clear? Yes? Chỗ này có vấn đề gì không? Hả? Không đúng không? Good.
Mong thế.
Okay. Try to work on it. Do you want to have 5-minute break?
Yes,
Yes?
really need.
Okay, thank you. So let's have 5-minute break and we'll be back and explain things. Cái đoạn thầy giải thích D11, D10, D9 mọi người có ok không? Có hiểu không?
Em hiểu một điều.
Thầy ơi, nhưng mà như cái này như là học ở lớp 10, nhưng mà lớp 10 thì ít cắt những cái lớp D rồi.
Không.
Ok. Bạn của em cô bạn của em có nói là ở lớp 10 các bạn rất ít học các nguyên tố D đúng không? Bởi vì các thầy cô không muốn các element D ấy, thì rất là nhiều electrode đúng không? Nên là sợ mọi người hỏi, tại vì là mọi người đang phải nhớ rất là nhiều, đúng không? Thế nhưng mà ở đại học ấy thì thầy nói thật là những cái nguyên tố mà sp ấy thì nó còn lại không bao nhiêu đâu. Kilo là cái ông mà đáng học nhất, tại vì là nó là cái mô hình đơn giản nhất, đúng không?
Vâng.
Thế sau hydro mà những nguyên tố nào mà thuộc lớp sp mà quan trọng, thứ nhất là lithium, đúng không?
Vâng.
Lithium có 3 electron, tại sao nó quan trọng? Tại vì nó làm pin lithium, đúng chưa? Sau lithium thì nguyên tố nào còn nguyên tố quan trọng nữa? Carbon, đúng không?
Vâng, cảm ơn.
Tại vì carbon nó là cái thứ mà quyết định tất cả mọi thứ organic chemistry sau này của bọn các em, đúng không? Thế ngoài carbon, ngoài lithium là thì nguyên tố Sp nào nữa quan trọng? Là silicon, đúng không?
Vâng.
Đúng không? Các em đã nghe về cái tên thung lũng silicon bao giờ chưa?
Chưa. Thung lũng silicon.
Silicon Valley nghe bao giờ chưa? Rồi, đúng không? Mấy ông ICT rồi phải nghe suốt, đúng không? Thế tại sao người ta gọi cái thung lũng đấy là thung lũng silicon? Tại sao?
Cái gì đấy? Silicon Valley là cái gì?
Đúng rồi. Tại vì á, cái cuộc cách mạng công nghiệp lần thứ 3 nó gắn với cái nguyên tố là nguyên tố silicon. Tất cả các transistor nó được làm lên từ cái nguyên tố silicon đấy, đúng không? Và tất cả các chip liên quan đến mạch điện tử của các em bây giờ á, là nó làm từ cái silicon đấy, từ cái mạch silicon đấy, hoặc từ những cái transistor silicon đấy. Thành ra là tất cả những cái công ty ở cái thung lũng đấy nó làm về electronic, nó làm về computer, đúng không? Thì người ta gọi cái thung lũng đấy là thung lũng silicon, tại vì tất cả nó liên quan đến một nguyên tố thôi, là silicon. Chứ không phải đấy là chỗ có nhiều silicon.
Lần đầu anh nghe thế đấy. Cái này. Tạm thế đi. Thôi kệ bác đọc công rồi. Mong là bác không đấm đi.
Hả?
Em chưa kịp ăn sáng.
Thầy có kịp ăn sáng.
Em mong là bác lao công không xông vào đây đấm. Lao công ở đây đấm phát. Em muốn ăn sáng của em. Em có 2 cái bánh.
may I propose that we try to continue because we have only half an hour to finalize our lecture, okay? Is it okay? Please. So first, let's work on this question. The electron configuration of silicon is A or B?
A.
And?
A.
A, right?
A. Yes.
A or B?
A.
A, okay. The electron configuration of boron is A or B? A, right? So maybe all the correct answer are A's. Joking. So A, right? So pick up 5 electrons, you feed from the lower energy to higher energy. So 1s first, 2s, and then 2p. So A is correct answer. B is not the correct answer. Okay, ready? What will happen if one atom inside the silicon crystal is replaced by one boron atom? So, imagine that you have a silicon crystal, like this one, silicon, silicon, silicon. Okay? So if we have silicon crystal, that means each silicon will bond with 4 other atoms, right? Because silicon, you see that you have 2 electron S and 2 electron P. So basically, you have, later we go, you have 4 valent electrons. That means the electron can participate in the chemical bonding, the outer layer, right? So here you have 4 electrons, that means you can make 4 covalent bonds. So imagine that you take this silicon, it will bond with 1 here, 1, 2, 3, 4. So you make 4 covalent bonds. The question is, imagine, look, I remove this one, but I put back a boron. Instead of silicon, I pick up 1 silicon and replace it by 1 boron. What will happen? What will happen? Is it clear, the question?
I don't think that's possible.
So the ball and will only connect with the 3 silicon and 1 electron free will become electron current. When there will be 1 free electron. Yes. It's from the silicon.
Okay. So, the question is extremely important for the silicon valley and for all the microelectronic technology. If you have silicon, it's 4 electrons. You have 4 electrons, right? Now, imagine that you have 1 silicon out and you put back 1 boron. How many valent electrons in boron you have? 3, right? So, imagine that you pick up 4, you put back 3. What could happen? There is 1 less, right? There is 1 less electron. Normally, that position, you have 1 silicon, that means you have 4 electrons available. Now, this electron is out, you put back 1 boron, and boron can bring only 3 electrons. So instead of having 4 electrons, now we have only 3, that means you have 1 electron deficit, 1 electron less. An electron is negative charge. So if you have one electron less, it looks like you have one positive more. Is it correct? So your friend say that you create one hole. Hole with a positive charge equal to the electron you want. Okay? Electron is negative, hole is positive. So let's say if you take out one silicon, you put back one boron, you will have one electron less, or it also means you have one positive more in the system. Is it clear? Okay. What will happen if you do the same thing, but instead of taking out one silicon, you put back one boron. Now you take out one silicon, you put back one nitrogen. You got my question? So to answer, how many valent electrons in nitrogen you can have? Huh? 5, right? Now you take 4 silicon from silicon, 4 electrons from silicon, sorry. You put 5 electrons from nitrogen. So that means each silicon you take out, you put 1 nitrogen back, you will have 1 electron more. Is it correct? You pick up 4, you put back 5. So you have 1 electron more. Okay? So in that case, you will have extra electron in the system. Imagine that you take 1 silicon, you replace by 1 nitrogen, you have 1 electron more. If you pick up 1000 atoms of silicon and you change by 1000 atoms of nitrogen, you will have 1000 electrons more in the system. Right? Is it clear? In the case of boron, you take out 1000 atoms of silicon, you put back 1000 atoms of boron, you will have 1000 electrons less, or you have 1000 hole more. Okay? Now, the second question, which is important for microelectronic industry. Here, if you have silicon, perfect silicon, old silicon, nothing else. You have another silicon, okay? Also perfect silicon. You put the 2 silicon in connection, what will happen? Can you imagine my question? You take 2 species of silicon. One silicon, another silicon. You put close together, interface, contact. What will happen? My question, simple, do you expect that there's electron flow from the left side to the right side, or right side to the left side? Huh? Do you understand my question? If I have 2 perfect silicon, okay? Perfect, nothing else. I put this in the interface that means interacts. Do I expect the electron flow from the right side to the left side, or left side to the right side, or nothing else? Huh? Nothing, right? Because they have the same level of energy, they have the same number of electrons, right? Is it correct? Cái chỗ này các anh em có hiểu không? Để thầy giải thích tiếp. Hiểu không? Nhớ cái nguyên lý bình thông nhau nhá. Nếu mà 2 cái bình mà có cùng cột nước mà em nối lại, em mở van ra thì chẳng có chuyện gì xảy ra cả, đúng không? Nước nó không chảy từ bên phải sang bên trái, mà không chảy từ trái sang phải, 2 cái mực nước bằng nhau rồi, đúng không? Ok chưa? Now, imagine I take the left side. Instead of having silicon pure, I have silicon with some boron. Let's say silicon with 1000 atoms of boron inside. I have less electron than the normal one, right? I take the right side, which is silicon. Inside, I already replaced 1000 atoms of silicon by 1000 atoms of nitrogen. So I have 1000 electrons more. Okay? Now, I take the two silicon in interface. What will happen?
Chamfer electron.
Okay, imagine guy. I have a left hand side, I have silicon normal and silicon normal with 4 electron each, right? Perfectly. So the number of electron in the left side and number of electron in the right side will be perfectly equal, right? Okay? So imagine that you have a 2 column water with perfect level of water. Now I make it contact here. I open this connection. The electron, because the level of water will be equal already, so there no water flow from this side to this side or other side, right? So that's for the case of perfect silicon. Now, instead of taking the perfect silicon, I use Bohr silicon. That means I take 1,000 electrons, 1,000 atoms of silicon, I put back 1,000 atoms of boron. So it means that because each time I put one boron, I have only 3 electrons. I pick one silicon, I pick out 4 electrons. That means each atom of boron present, I will have 1 electron less, right? So it looks like now I have this level of water. Is it correct? Because the level of water represents the number of electrons present inside. The same scenario for the nitrogen silicon. Each time I put 1 nitrogen, I have 1 electron more, right? Because silicon is 4 electrons, now nitrogen is 5. So I take 4, I put back 5. So that means the level of the water here, level of electron will be up. I have more electrons, right? Now I take boron silicon, nitrogen silicon, I put it in contact. So now if I open this one, what will happen? The electron, water will flow from this side to this side, right? So it's like the electron will flow from this side to this side until it reaches the equilibrium, right? So in that case, we have nitrogen silicon, boron nitrogen, boron silicon, you put back like this, the electron will flow from the deep right side to the left side. So when the electron flow, what will happen? You create the electric current, right? So this also means the electron can flow only from the right side to the left side. If you want to make the electron flow from the left side to the right side, it's impossible. So that is principal operation of what we call the silicon transistor. I mean, it can flow only one direction, but cannot be back. Okay? So all the microelectronic technology based on the electron flow from the nitrogen doped silicon to the boron doped silicon, from the extra electron to the deficit electron. And if someone of you are studying energy department, you know that all the photovoltaic technology nowadays on the silicon, Vietnam is second producer in the silicon solar cell, especially in Bắc Giang and Bắc Ninh industrial park. The operation of silicon solar cell is basically based on this phenomenon, because when electron flow from this side to this side, it creates the electric current. Okay? Is it clear? So, the key message I want to tell you is that learning about electron configuration is not for fun. It's not for examination and then on. Learning about electron configuration to understand better the phenomena that we are using to make money. You got what I mean? Okay. So you see that silicon in the 4A. So basically, people nowadays can replace silicon by boron because it's a 1 electron less. It can also replaced by nitrogen, phosphorus, or some people replaced by arsenic. Because you have a 5A. Now, next question. You can ask question like, okay, then why don't I replace silicon by the atom like this one? Because they are in the same 3A column as well. Why we prefer to replace silicon by boron, but not by, for example, this one here. Even they have a 3 electron, right? So if you take out one silicon, if you put one helium, you have the same deficit of electron. So why don't people use indium, but they prefer boron? Any suggestion?
I think the radius of boron is smaller, so it's
Yes. Because not only the question of number of electrons, but also the question number of the dimension of the atom. Let's say, this guy is sleeping, right? He occupies this position. Now I prefer to pick up this guy. Okay? Replaced by someone else. But if I replace by someone like double size of this guy, the two guys will not be happy, right? Because the position normally occupied by some tiny guy like this, so they are the two guys feel comfortable, right? But if you put like someone like 2 times bigger than this one, the two guys will not feel very happy. At one moment, they go away. Okay? So the crystal will break that. So the question of the dimension is also important. Normally, if you pick up something out, you replace by the smaller radius, smaller atom, the system will be okay. But if you replace by the bigger one, it can obey at some level. But the population of the bigger guy occupied increase, the crystal will be not stable. So that's the problem. Okay? So, okay. Relevant to the question, good mark from this guy, he said that at high school you talk a lot about the S-P element and you don't talk too much about the D element, right?
yes.
First, because the number of electrons in D element is very high, so if you need to remember and write down the electron configuration with, let's say, 30 electrons, it will take time. So that's why your teacher at high school prefer to work with the number of the electron limited, like 10 or 20, 10 or 12, so you will have time to work on the electron configuration. But at the highest university, I emphasize that the beauty of chemistry rely on the D element. Why? I say that. Because all the enzymatic process, the biological process rely on the catalyst we call enzyme, right? And all the active sites of the enzyme are made of the cargo of the D element. So when we want to understand biological process, when we want to understand the chemistry related to the biological process, you need to understand the D element. So that's why we focus our study in the D element. Okay? So here you see that some enzymatic system will have the D element. So guys, after my lecture, you can forget all the elements if you want. But at least few elements you need to remember. Hydrogen, lithium, carbon, silicon, oxygen, 5 elements, right? And 3 elements transition metal, D element, iron, cobalt, and nickel. So, the element you need to remember: hydrogen, lithium, carbon, oxygen, silicon, because all the elements related to the living system or in the tree. And 3 transition elements: D element, iron, cobalt, and nickel. Okay? Huh? You can forget anything if you want. So here are some enzymes made of iron and nickel. I will not. So go to what we call the condensed writing electron configuration. Imagine that if you take the layer sodium, you have this electron configuration, right? You write it this way, it will take quite good time to write out, and also it take space, right? So you can write in the short, you can write in the full electron configuration like this, or you just use by the what we call the condensed one. You replace all the 1s2, 2s2, 2p6 by the electron configuration of the noble gas before, which is neon. So you have this condensed simple electron configuration. You know very well, right? So it's like in the matter of the comparison of the electron configuration of the atom you are examining with the electron configuration of the noble gas before it. So you pick the noble gas before it and you put up the valence electron. So this one we don't have no problem. So you will see that the element with the similar electronic structure of the outer cell we call the valence cell. Why the valence cell? Because the electron will participate in the chemical reaction, participate in making chemical bond. So we call the valence cell. So all the elements with the same electron, same number of electrons in the valence cell, they will be in the same column. For example, 1A, you will have hydrogen in 1s, lithium 2s1, sodium 3s1, and so on, right? So you see that they will have the same electronic configuration if you remove the noble gas before. Okay, so here you have the second column, then a problem. Okay, so as I mentioned, you distinguish the two class. You make a classification of the element based on the valence electron. If the valence electron localized in orbital S and P, you call the element belong to the block S or P. So if the valence electron localized in the orbital S, we call the block S element, right? For example, the sodium, lithium, hydrogen belong to block S element because the valence electron localized in the orbital 1s, 2s, 3s, and so on. If the electron, valence electron, the outermost one, localized in the orbital P, we call the element belong to the block D element, right? So, and also you have block D element because you have the orbital D. Yeah? You have 5 orbital D, so you have 10 electron at most, so you have 10 column of different number of electron D, right? And all the orbital S and D we call the main column. So in the periodic table of element you put the A, column 1A, 2A, 3A, and so on. And all the elements belong to the block D and F, we put in the D column, right? Okay. So, what could be the electronic configuration? Electron configuration of iron 26. A, B, C. Which one?
R bao nhiêu hả? Dấu R.
A, B, or C?
Ban từng người nhé. A.
A?
Dạ, A.
A. B.
B?
B.
A or B?
B.
B, right?
B. Vấn đề ở ngoài.
Because 4s is lower energy than 3b. Okay? But to be honest, if you write A, then no problem to me. Okay? Next, what could be the electron configuration of iron 2+?
A. A.
A, B, or C?
A.
A.
A. The fuck B. D.
Huh?
Cái đó là A. Kệ các bạn thấy kệ
B.
nào.
A. A is correct answer. Okay.
Đồ rất lớp 10.
Teacher, that's 2 plus is get it the 4s. 2.
Yeah. Why is the reason? So the correct answer for the first question is B, right? 2s, 4s2, and 3p6. 4s2 a lower energy level, but it's an outer layer, right?
Yes.
So when you remove electron to make iron, the electron from outer layer will go first. You get what I mean? So the correct answer should be A. So what will be the electron configuration of iron 3 plus?
Chắc là bằng A thôi vậy.
Huh?
A.
The same, right?
Yes.
So now you clear 2 electron S already, you have 6 electron D for 2 plus, and you have 5 electron D for 3 plus. Okay? So, by definition, because iron 0 is the 8th element, because you have 2S and 6D, you have the 8th element. Iron 2 plus become the 6th species, the 6th iron. And iron 3 plus become the 5 species. Is this okay?
Yes.
Okay. What could be the cobalt?
A.
B chứ. Lại nhờ.
Sao?
B.
It's the same, right?
A mà lúc nãy vừa chữa là cái lớp 3D nó bên
Không đáp bằng cái kia cơ.
B.
B, right?
Yeah, B. Xin lỗi.
So, what could be cobalt 2 plus?
A.
A, right?
Remove the
What could be the cobalt 3 plus?
A.
A, right?
A.
So, that's why explanation why you have the phenomenon. So you have D6, 3 plus. So all the when you have 6 molecule water surrounds, you have this fitting I explained already, and no problem. And I already explained to you why we see the color of one camera.
Good test
Right?
đây.
So if one camera absorbs red color, you will see the green color. If it absorbs orange, you will see the blue. If it absorbs violet, you will see the yellow. So we move to the last 2 questions. Last one. Please write down the electronic configuration of the following species. What could be the molybdenum 5 plus electron configuration and 6 plus electron configuration? Quick.
Viết cấu hình E.
Trả lời nhanh cái thầy D mấy?
Không việc gì bạn nhé.
Okay. So,
Không việc gì bạn.
what could be the electron configuration of the molybdenum 5 plus?
Ba tiếp thì vui à.
D what?
One actual.
5 plus will be D. 1, 2, 3, 4, 5, 6.
For the 5. 45. 45.
Huh?
S1 45. Biết đọc thì em chắc cao biết. Chả lắm.
What could be the electron configuration?
Đọc cái chỗ này đi.
P. So, molybdenum 5 is D1. Molybdenum 6 will be D0. Second question. A compound of molybdenum. So this compound, the structure here. So a green color. You see the color of sample. I pick up from my research lab, not imagination. What could be the oxidation state of molybdenum in this compound, whether molybdenum 5 plus or 6 plus? Huh?
It look toxic to you. Yes. No. Câu hỏi thầy cái này này có toxic không?
What could be the color of this camera? Huh? 5 plus or 6 plus? So we back to this case, for example, right? So if you have molybdenum 6 plus, that means you have D0, right? So if you have D0 and you have a splitting of 5 orbital D, 3 at lower energy and 2 at higher energy, but you have D0, that means no electron in the orbital D, right? Is it correct?
Yeah.
So there are no electron in the orbital D, so electron from the orbital D cannot absorb any photon to get excited. So if this camera have no orbital D electron, it cannot absorb the photon, it cannot absorb photon, own photon from the sunlight, will be transparent, so the camera will be colorless. Is it correct?
Yes.
You will see the white color. If you have a molybdenum 5 plus, you have 1 electron, right? D1. So 1 electron will nuclei here on the lower energy level. Okay? So when you send the photon, it will absorb the photon, get excited here. So you see the color because it absorbs the photon. Okay? So basically you see the green color. Sorry. You see the green color here because it absorbs the red photon. Okay? So you see the spectrum, it absorbs the red photon, so you see the green color. So exactly the theory we learned, not something imagination. Okay? So for sure, the camera will be molybdenum 5 plus, not 6 plus, because 6 plus will be colorless. Next one, the smart window. The molybdenum, the tungsten 6O3, so tungsten 6 plus is colorless, the same, because you see that tungsten and molybdenum, they are in the same column, right?
Yes.
So tungsten 6 plus is also D0. And if you have D0, it will be colorless. So tungsten of 3 is colorless, but when it reduces state tungsten 5, that means you put 1 electron more, so the tungsten 5 will become D1, right? And D1 shows the blue color because it absorbs photon. Okay? So if you make the smart window of tungsten oxide, in the normal state, tungsten oxide will be in the D0 tungsten 6, so it has no color, so the window will be transparent. If you apply electrical current, the tungsten will be reduced to be tungsten 5 plus, so it becomes blue color because 5 tungsten will be D1 element, and D1 element can absorb the sunlight. Is it clear? Huh? So you see that all of this thing is not something I imagine. It's already available in the market. And this available technology in the market is thanks to the understanding of the electron configuration. Right? So it's not try to write D2, D3 for fun. Because you need to understand D2, D3, D5 and so on to understand the physical and chemical process that you see in the market product and in the technology we are developing. Okay?
Okay.
So we end our lecture here. Do you have any question? Yes? No?
Why do we see the sky is blue, not green?
Sang học địa lý bạn ơi.
Okay. Very nice question. Then Vietnamese expression to say trời xanh, mây trắng, nắng vàng. Why that? Okay? That is that. Straight away. Okay? So we'll talk about this question later, okay? In the next section because the time is now. So that's, thank you. This very beautiful question. We have the process absorption, transmission, scattering. Okay? And the expression trời xanh, mây trắng, nắng vàng representing, explaining by the process of scattering. Okay? Thank you.